Good afternoon. Welcome to Observability conference. My name is Jason. So I'm going to talk about some innovations and the latest advancement in the cloud infrastructure. So let's look at this, how we're going to support our customers on Alibaba Cloud. We are supporting more than 50% model companies in our Alibaba Cloud. In addition, more than 80% technology companies are running on the Alibaba Cloud. So we have a lot of customers running on the Alibaba Cloud. Inside this, with these customers, actually we, as a cloud infrastructure, as a cornerstone to support all these customers, providing compute, storage, and networking. Just like Hong mentioned, I think one of the biggest things actually happening this year is we are pioneered the transition from satellite broadcasting to cloud broadcasting through OBS 3.0 cloud service. We support OBS 3.0 cloud system on top of Alibaba Cloud. So I think you just watched the video. There are a lot of interesting points inside that video. So here I just want to add one point. We actually inside this broadcasting service, a lot of AI technologies have been utilized. So in the other hand, actually cloud computing fusion with AI technologies facilitated the adoption of AI technologies by business companies. So we will see a lot of technologies through cloud computing utilized in your business logic. So here, one thing Hong just mentioned, we have a multi-camera ready reconstruction. So here we have a second level spatial reconstruction and a 3D dimension. And also we provide a lot of new broadcasting experience with our viewers. So the next one, actually, the user scenario actually is Xiaohongshu. I'm not sure if here we have some users from using Xiaohongshu. So I'm one of the users. Actually, when last month I went to Korea, like Jeju Island. So I almost completely depending on Xiaohongshu to find out the sightseeing, the coffee shop, and all the sightseeing spots. So it's a very popular app with more than 300 million users. So we are very proud of running Xiaohongshu on top of our Alibaba Cloud. And also we collaborate with the team from Xiaohongshu, making a lot of technology innovation to improve their efficiency, to reduce their cost. So from CPU utilization point of view, so Xiaohongshu completely use our container service, and plus the coordinator scheduling to hybrid deploy online service and offline service together, which can improve the CPU utilization. And the CPU utilization is up to 45%. So that's how we improve the CPU utilization inside the Xiaohongshu system. So another part, actually, they have a lot of good recommendation and a search system. So based on this system, actually, they train a lot of data. Utilizing the ECS 8th generation AMD instance, their training system performance is improved by 30%. So the third thing actually is very interesting. Xiaohongshu probably has built the largest data lake system from the industry. So they built their data lake storage on top of OSS. Our OSS provides more than 100% double the data throughput to meet their very large scale data set. So from these two user scenarios, actually, we're very proud of supporting these customers with their very rapid growth. In addition, let's look at some of the requirements from machine learning and the deep learning domain. So when we look at the computing requirements from AI part, we found that every year, the compute requirement is 4 to 5 times increase. So in addition, here the IDC is estimated in China, the CAC rate of China intelligent computing power actually is increased 34% every year. So here one example I want to show you is that from the recent report from the Meta, it reported that the compute power used by training 3.1 4 to 5 billion model is more than 50 times than the compute used in Llama 2. So just like a 2 years time frame, the compute requirement is increased by 50 times. So on the other hand, the AI growth actually put a lot of pressure on the requirement of high-performance storage. So there are a couple of reasons. So one reason is that the number of parameters named the model size is increased 10 times per year. And also the training data sets named by the token in the training model is increased by 50 times every year. So those growth actually put a lot of pressure on the requirements of storage. So the checkpoint becomes bigger and bigger, and the frequency of checkpointing is much more frequent. And also the load and also the distribution of those model files and the checkpoint files requires a lot of bandwidth. So this actually is a very demanding requirement for a storage system. So to support those customers and also to meet the requirements from the AI growth, so we think, and we have been working on these 3 parts. So one is that from the cloud infrastructure point of view, we need to provide a large scale and cost-efficient infrastructure. Secondly, we need to provide a high performance and a highly reliable infrastructure. The third part is we have to provide easy to use and intelligent infrastructure so that we can improve the productivity and improve the efficiency. So as Han just mentioned, we have a very integrated full stack of AI infrastructure. So inside this AI infrastructure, we have quite a few building blocks, including our AI compute server and the HPA networking and storage, and also Lindrum computing cluster and the Pi and our container. So 2 points I want to add here. One is that if we look at the large language model training process, we'll see there's a lot of interruption along the way from the Llama 3.1 4.5b model training report. So inside the span of 54 days, they have 466 interruptions. So that means every 3 hours, there will be an interruption. So we have to reload the checkpoint and then start the training again. So every 3 hours. So for us, we actually put a lot of efforts trying to reduce the number of interruptions and also trying to reduce the interruption period. So even we have an interruption, we want to minimize the interruption time as much as possible. So then we have put a lot of effort, including fault tolerance, fast checkpointing, and a fast checkpoint load, and also migration, proactive fault tolerance detection, so that we can put the uptime of a model training up to 99%. So that means if we could run the Meta Llama 3.1, probably we can just have 1% of the time lost because of these failure interruptions. So on the other hand, we also have a lot of optimizations to improve the utilization of GPU. So compared to the open source version, we have more than 20% improvement over the open source version. So here, just based on what Han just mentioned, I put a few data points here to share with you guys. So basically, we can scale up to 150 1,000 GPUs from the high-performance networking 7.0 architecture. And also, we have this linear scale of performance. So we have 1,000 GPU cards, and then we can scale those 1,000 to 100, to 10,000, or even 100,000. So along this scaling, the performance actually has an increased rate of more than 96% linear rate. So that means like when we add 1,000 GPUs, we can add the full capacity of 960 GPUs. So that's kind of the efficiency of 96 means. The second one is the bandwidth utilization. In the scale of 10,000 GPU cards, the high performance bandwidth can be utilized up to 99%. And also we provide this 20 terabytes of horizontal scaling, and we provided the 20 terabytes of storage throughput from CPFS. So that's probably give you a quick overview of how much performance we can deliver from our Linjun supercomputer for our AI applications. So the second part, I want to share some of the advancement and also innovation from how we're going to provide the high performance and a highly reliable infrastructure. So the first one actually is CIPO 2.0. So I think some of you might be familiar with the AWS Nitro system. So started from 2017. So I think we were the first cloud provider to offer this cloud infrastructure process unit architecture. Along the way, we have actually improved this system a lot, and this year we're going to release CIPO 2.0. So with the CIPO 2.0, we have improved the host stability by 20%, and also the bandwidth has been improved from 200 gigabits to 400 gigabits, and also we still offer the best-in-class elastic block storage performance by providing 6 million IOPS and 50 gigabytes per second throughput. So this is actually the kind of the leading performance among all the cloud providers. And also CIPO 2.0 supporting the comprehensive security capabilities from the root of trust to the hardware data encryption to the trusted computing environment. And also, besides supporting Intel and AMD computing instances, we also provide ARM-based computing instance based on our own E10 chips. So in our E10-backed ARM computing instances, we did a full stack of optimization from operating system, from the compiler, from the application layer optimization. With all this optimization together in the big data scenario, our E10 instance can provide 40% more performance. And also in the video transcoding scenario, it can deliver more than like 30% of performance compared to regular x86 instances. So Huang just mentioned the container computing service. Here, I just wanted to add two things here. So one is the fine-grained the computing resource. So we can actually start with very small instance, like like 1/4 of a core and 0.5 gigabytes of memory. So with this fine-grained computing instance, which can tailor with your application need. So when your application workload is a fluctuation, like you need more CPU to process your data, or you need less CPU to process data. So this instance can be dynamically adjusted to meet your needs. Actually, this can reduce your cost significantly. Here, I just give you some quick heads up on how we developed in the computer side. So here, I want to spend a few more minutes to talk about storage and talk a little bit about networking. On the storage part, we actually optimize the object storage service for data and AI. So as you know, we have a different storage classes for cost optimization. In addition to that, we have we did a lot of optimization for supporting AI and ML workload. For instance, we released the new version of SDK, particularly for optimization for Go and Python. So if you application using Go and Python, so the performance improvement is up to like a few times of much faster. Then we also have a very diverse integration with the different analytics engine and also AI frameworks, so that we can use OSS as a unified storage pool to do training, to do like an inference, to do data processing and data analytics. For the network part, I think one of the key issues in our networking part is that how we can deliver the consistent performance. As we know, the communication path is very long. So there's a lot of devices and a lot of systems in between. So a lot of outliers can happen, which can bring the long tail latency is very long. So that we did a lot of optimization to reduce the long-term latency so that we can deliver the consistent performance for our application. So here, last year, we actually provided the proactive reroute technology across the region. So you have two computing nodes from different regions, so that in between, you may have a lot of devices to affect the latency, so that we can do the reroute if some device is failing. So this year, we actually applied the same technology for the communication between two data centers within the one region. So we actively monitor the performance, and so that if we can encounter some long latency, we can switch to a new route, so that we can reduce the long latency to provide the consistent latency for our application. So the third part, actually, we know, and also we believe we need to provide an easy-to-use and intelligent infrastructure for our developers. So the cloud computing actually is designed for developers, so that we can provide much better productivity and deployment and maintenance efficiency. So many of you might give us a lot of feedback about how complicated our console is, and how hard we're going to use the console to deal with the Alibaba Cloud services. So this year, actually, we took our customers' feedback, and we did a lot of improvement by improving the usability of our console. And also, we also utilize AI technology to build a lot of AI copilot. For instance, we use our AI copilot to recommend elastic computing instances to match with your workload characteristics. And also, if you have some questions to be asked, so then our chatbot of AI copilot can answer your question from our documents. And also, we did a lot of improvement on the infrastructure as a code, so that we build a lot of deployment tools to improve the deployment efficiency, the maintenance of your resources on the Alibaba Cloud. Another big key aspect of using Alibaba Cloud services is observability. So you want to understand what's happening in your application, and also you want to know the insights of Alibaba Cloud services, so that we know how to analyze the performance, how to analyze the capacity, how to understand where the cost goes. So we provide a full stack of observability. We provide a set of cloud lens to help our customers to understand where the cost goes, where the performance goes, where the capacity goes, so that we can better manage and also deploy those resources. We also provide the full stack of observability for our AI stack so that the AI applications can run on our AI stack efficiently and more productively. So as I mentioned, we support a lot of customers running on our cloud platform. We are very grateful to go with those customers, and also we are very excited to go together for the new AI journey. Thank you very much.